Hello, everybody. This frightens me to death. And I say every conference or seminar needs somebody for a bit of light relief. Well, that's me, folks. Now, this talk is maybe about computer programming in the 60s, but it's very much anecdotal. If you want the technical stuff, you'll have to go onto the internet for it, because it's not here. Looking back after 50 years, because that's what it is, I can't help but wonder how on earth I got into programming. I'd never seen a computer. I didn't really know what they were about. And somewhere the idea came from, but I don't know where. But I sat down with a London trade directory and wrote to because I was living in Watford at that time, and I wrote to everybody that I thought could have anything whatsoever to do with computers. 60 or 70 letters on an old-fashioned stand-up and beg typewriter. I got 2 replies. One, a polite no thank you, and the other one from Elliot Brothers at Borehamwood saying, ring up and get an interview. So I did. At the interview, I was given 2 questions to answer, 2 problems to solve. One involved triangles and angles, which initially stumped me until I remembered SOHCAHTOA. Can anybody know what SOHCAHTOA means? And the other one involved rowing 3 items across a river in a little rowing boat that would only take 2 of them, a fox, a goose, and a bag of corn. You could only take 2 across at once. How do you do it? I see lots of nods. You obviously know you put 2 in the boat, bring 1 back. Because if you left the fox with the goose, the fox would kill it. If you left the goose with the corn, the goose would eat it. Anyway, I got through that problem and obviously convinced the chief programmer, a guy by the name of Chris Mason, that I have a relatively logical mind, so he took me on. Now, I have to point out that I left school with a bucket full of O-levels, but nothing more, no A-levels and no chance of a university degree. So I think I was very, very lucky to have met Chris Mason and to get to Elliot's, because Chris already had a girl working for him called, nowadays, Janet Williams. I'm afraid I can't remember her name then. And she'd got there via an agency run by a lady called Dina St Johnston. Dina's husband, Andrew, was a joint managing director of Elliot's, and they'd obviously realised that computer programming was the way forward. Programmers would be needed. So Dina set up an agency. Dina had written an article for Electronics Weekly saying that it was not necessary to have a degree or to be a mathematical genius to write computer software. Janet had seen this and applied in 1961, and she became Dina's first trainee programmer. I think she was as lacking in formal education as I was, but she proved to be a very able programmer, and she subsequently went to work for Elliot's and therefore set a precedent. So you don't have to be highly qualified to be a programmer. You just have to have good training and perhaps a certain frame of mind. Now, I'd like to say a big thank you to Andrew, believe it or not, for asking me to come here today, because it made me I have to apologise. It made Frank do some research into Elliot's. And I discovered that they were actually a very interesting and innovative company. I certainly didn't know it when I worked for them, I think because I was just so involved in what I was doing. But I realise now, looking back, that I was working in what was very much a research department. The company made and sold computers, but they mostly sold systems, i.e. computers that were adapted and programmed for specific jobs. So here we have a jolly old Elliot 8. Does this ring any bells with anybody? Trust Andrew, yes. Here we have an Elliot 803. Very simple machines, basic simple machines. And although you could get vast reserves of memory with your magnetic tapes over there, the actual machine had very little. It consisted of a 4096 word core store, and each word was 39 bits. A bit is plus or minus electricity, effectively. Now, that's not a lot. We worked in machine code, i.e. numbers. Every task had to be broken down into the tiniest little part, and you started every job by drawing copious flowcharts to see how you could do it. Input into the machine was via punch paper tape, 5 holes wide with a smaller sprocket hole. Paper tapes were prepared using a teleprinter, and a single typing mistake could mean that you had to copy your whole tape again, up to the mistake, correct it, and then carry on copying. It was all very slow and laborious. And you soon learned how to read paper tape because it was all in binary. And I actually had a splicing machine so that you could cut out a mistake and splice a correction into it. And I think you think about the magnetic readers and the splicing machine. Borehamwood was very close to Elstridge Studios, and I think the sort of technology jumped the two disciplines sort of thing. Programs were made up of instructions of 6 bits and a 13-bit address location, because with so little memory, so little storage, you had to know where everything was. You couldn't waste any space. Now, to input your program into the machine, you'd first to load a tape called T2. This was obviously a very basic operating system. There were instructions actually wired into the computer into locations 0 to 3, and you activated these by putting a couple of instructions by way of buttons on the console. You've got the console. I have to talk to you, don't I? The console is there on the left, and it had lots of push buttons to put your instructions in. And once you got good at this, my word, you looked impressive, pressing these buttons and making things happen. Now we've got used to the speed of computers nowadays. And if things don't work instantly, we get impatient. Well, I do, don't I, Frank? I did this morning. But I remember wanting to do a very, very simple number crunching exercise. Very simple, but just looking through a lot of data. We had an old 803A machine, which we were allowed to play on. And we set this program going first thing in the morning and went back after lunch to see if it had actually got there. And of course, machines were transistorized and generated heat. And we didn't have air conditioning, fancy stuff like that in those days. And I worked in a place with a glass roof, you know, like the mills round here. So on hot sunny days, you had to watch the temperature. You had to have a thermometer, not for our comfort, but for the comfort of the machine. And it probably only worked in the morning, so you had to pack up in the afternoon. Now, fax machines are old hat now, aren't they? But I can remember getting very excited by being asked to experiment with linking the firm's telex machine to the computer. As I'm sure you know, with devices like this, to get a connection, you send a signal out, you wait for a signal to come back, and then you send your message, controlled by the 3 different parts of a jack plug, tip ring and sleeve. Well, in order to do this, the engineers had to create 3 special instructions for my machine so that I could do my experiments. So I had my own circuit board, and when I wanted to play, I had to go and put my circuit board into the cabinets. And our experimental cabinets, I can assure you, were a lot bigger than those. They were huge. So I then had to book an appointment with the person in charge of the telex machine. I was only given a very few minutes, so I had to rush back and activate the program, send a message and get one back. It's all terribly exciting. Now, when we switch on the computers nowadays, they go automatically into some form of systems check. And that was another thing I was involved in, both at Elliot's and later at STC. Now, it was at STC that I was very frustrated because I'd written a program that tested every instruction out and went through every path through every wire and circuit in the computer, and it ran perfectly for hours on end. But when I set it going overnight, repeatedly, it failed at round about 3 o'clock in the morning. Now, the only thing we could put this down to was the fact that we were located right next door to Cockfosters railway station, and I think there must have been a big power surge at around 3 in the morning. Because again, we're used to surge-protected plugs now, but we hadn't got them in those days. Now, whilst at Elliot's, I worked on several contracts. The one at Filingdales was interesting. It was the 3 great big radomes in those days. And the Americans, because it's basically an American base, they allowed us to tap off some information, and it was displayed on a great big board in what was called the UK dip room. But to test that, I needed some simulated threat conditions. And these were provided on punched cards. And because we were all working in paper tape, we couldn't read punch cards. So I had to take them up to London, and I think it was to the War Office, to get them the information converted from punch cards to paper tape. Somebody's grinning there, it's lovely. You've obviously had heard of this sort of experience. So I got my data converted and I could test the systems out. I have to say that the worst place I ever worked was at Jarrick, Joint Air Reconnaissance in Huntingdon. I worked there with an engineer testing out their equipment, and it was so hush-hush, we were escorted every moment of the time. We were videoed and guarded all the time. It was like being back at school. Please, can I go to the loo? And I was escorted to the loo. Not very comfortable at all. Now, I gave up programming in 1968 to come north and to take up farming. Bit of a difference. But the strange thing is, real coincidence, I moved up here to near Hebden Bridge. And just down the road at Mythenroyd, there was a poultry firm which had started in a very small way. I do a talk on this, with a few broody hens and orange boxes. But they grew to be world leaders in the poultry business. Fascinating stuff, isn't it? So much so that when they launched a new breed of hen, and I hope you're not going to get offended by this, they did the launch at the Playboy Club in London. Now, they were experimenting with hybridization of chickens, and their research generated huge amounts of data. So they were obviously quite innovative and ahead of their times, because they purchased an Elliot 803. So here we see Cyril Thornber signing up for the computer. So the computer became part of Elliot's.
How much did it cost then?
60,000, was it? 30,000 pounds. So there we have a very brief insight into my life as a programmer. Thank you for listening. It wasn't techie at all, was it? So, thank you for listening. Thank you for Frank for helping me. And we will finish with a short video about Thornburs and the 803. And for any of you that remember Pathé films, you'll find it as evocative as I do. Thank you.
You don't seem to be getting any sound.
Oh,
You've got to get a sound.
yes, it's no good without.
Know what freedom is.
Brilliant.
The natural life outdoors isn't their birthright in the 20th century. For an egg-hungry world needs more eggs, better eggs, bigger eggs. The poultry farmer takes his notes, and away go the eggs. At the hatchery on a large concern, science comes into the picture, here measuring the depth of the white. As they know what sort of hen laid the egg, the quest for more, better and bigger is helped by the data provided by the laboratory. Weight is important too. Chicks by the million. The first thing to find out about them, their sex, cock or hen. It takes an expert to spot the difference when they're only a day old. What can they be doing with a computer costing £30,000? They're feeding it with the facts of life, poultry life. The vital statistics of eggs and chicks. So many facts indeed that no human brain could cope with them in the time. The computer uses codes, magnetic recording tapes and heaven knows what. It knows absolutely all there is to know about an egg, except how to lay it. Who would have thought that behind the eggs we all take for granted, there was all this science, all this industry? Some skeptics believe that the mass-produced eggs and birds lack the flavor and nutritional value of those produced naturally. Scientists, however, believe they will improve both quality, quantity, and size. Wonder if they'll ever be as big as this.
There you go.
Think about it.
How things change.